Welcome to the Deep Dive. Today we're tackling something pretty exciting happening in AI.
Yeah, what's that?
We're seeing AI agents really move beyond just doing one thing. They're starting to form these complex collaborative systems.
Definitely. Multi-agent systems.
Exactly. And they can handle much more intricate challenges. But, well, this kind of sophistication brings a whole new set of complexities for the developers actually building them.
That's absolutely right. Getting multiple AIs to coordinate effectively, autonomously, especially on demanding tasks, that's a big leap.
Yeah.
It requires a sort of fresh look at how we architect these things, how they talk to each other, how we manage them.
And that's where focus comes in today. Google, at their Cloud and XT event, NXT 2025, announced something called the Agent Development Kit, ADK.
Right, ADK, I saw that.
It's a new open source framework, and it's specifically designed, apparently, to streamline the whole end-to-end process of developing these multi-agent systems.
Yeah.
So, okay, let's unpack this. What is ADK, really, at its core?
Fundamentally, ADK is, think of it as a versatile toolkit, modular, designed to make the whole lifecycle of building AI agents simpler, especially those agents meant to work together in these, multi-agent setups.
Okay, simplifying complexity.
Exactly. It's trying to bring more of a, let's say, structured software engineering approach to building these AI teams. And what's really interesting here, ADK isn't just an idea on paper.
Oh.
It's actually the same framework Google uses internally for agents in products like Agent Space and their customer engagement suite.
So it's being used in the real world already.
Precisely. That gives it a pretty significant stamp of validation, doesn't it?
It definitely adds weight.
Ah.
Okay, so our mission for this deep dive is pretty clear then. We want to understand the core ideas behind ADK, look at its key features, and figure out why this is, well, significant for anyone involved in AI development or even just interested in where AI is heading.
Yeah, exactly. We need to get what makes ADK tick and why Google is pushing it as this key enabler for the, next wave of AI apps.
So let's get down to brass tacks. The docs, the Google developers blog, they talk about these core pillars of ADK. Build, interact, evaluate, and deploy. Let's maybe tackle each one, starting with build. What's crucial there?
Right, the build pillar. It's really about setting up the foundation for your multi-agent system, and there are a few key parts to it. First off, ADK is multi-agent by design.
Okay, what does that mean in practice?
It means it's built from the ground up to make it easier to create systems where you have multiple specialized agents working together, often in a hierarchy.
A hierarchy, interesting.
Yeah, so you can have complex coordination, delegation of tasks. It moves away from that idea of one giant AI trying to do everything. You get this flexible modular base. You can assemble AI teams from diverse skills, diverse knowledge sources. You're not stuck with just monolithic agents.
That makes a lot of sense, like building a team of specialists instead of one generalist trying to juggle everything. What else is important under build?
Another really vital piece is the rich model ecosystem. ADK isn't locked into just one AI model.
That's good, flexibility.
Absolutely. I mean, yes, it's optimized for Google's own Gemini models and the Vertex AI model garden, but it's explicitly designed to be model agnostic.
How so?
Well, it offers LaneLM integration, and that's pretty significant because LaneLM acts like a universal adapter. So ADK can talk to lots of different large language models from Anthropic, Meta, Mistral AI, others using a consistent interface. That flexibility is a huge plus. Developers can pick the best model for each specific agent or task in their system.
So you're not tied to one vendor. That's definitely a big deal for developers who might prefer certain models or have specific needs. What about the rich tool ecosystem? That sounds key for building useful agents.
Absolutely. Agents need to do things, right? That's where tools come in. ADK gives you access to pre-built tools like search or code execution.
Stuff, yeah.
Right, but it also supports something called Model Context Protocol tools, MCP tools. Yeah, it's basically a standardized way for models and tools to communicate. Helps ensure they work together smoothly, no matter the tech underneath. And crucially, ADK lets you integrate popular third-party libraries. Think LangChain, Llama Index, LangGraph, Crew AI.
So you can bring in existing capabilities.
Exactly. But what's really fascinating, I think, is that you can even use other agents as tools.
Wait, agents calling other agents as tools?
Yeah. So imagine you have a specialist agent, maybe for analyzing financial data. Another agent, maybe a project manager agent, could call on that financial agent for its specific expertise.
Like a human team manager delegating.
Precisely. That ability for agents to leverage each other really underlines the whole collaborative nature ADK is aiming for.
Wow, okay. That opens up some seriously intricate possibilities. The last point under build was flexible orchestration. What's that about?
Flexible orchestration deals with how you define the workflows, the interactions between all these agents. ADK lets you set up predictable pipelines using specific workflow agents, things like sequential, parallel, and loop agents.
So structured flows.
Right, for when you need things to happen in a clear, predefined order or way. But it also supports more dynamic behavior. It uses LLM-driven dynamic routing, sometimes called LLM agent transfer.
Meaning the AI decides where the task goes next.
Essentially, yes. The main AI can intelligently decide to hand off a part of the problem to another agent if it determines, based on the context, that the other agent is better suited to handle it. It makes the whole system much more adaptive. The LLM itself makes the call to transfer the task.
Okay, that's a really solid overview of the build pillar. Let's move on to interact. The big feature highlighted there seems to be built-in streaming. That sounds like more than just text chat.
You're spot on. ADK offers unique bi-directional audio and video streaming capabilities.
Bi-directional, meaning back and forth.
Exactly. It's not just about sending text messages. It allows for much more, well, human-like conversations. Think about an agent that can understand you speaking and then respond audibly, maybe even visually. That capability could seriously transform how we interact with AI agents, make it feel way more natural, more intuitive.
Yeah, I could see that.
It's pretty interesting to think about how these richer ways of interacting might blur the lines between, human and AI collaboration.
That really does sound like a potential game changer for certain applications,
Yeah.
definitely. Okay, so we build these sophisticated agents. They can interact in rich ways. How do we make sure they actually work as expected? That brings us to evaluate and built-in evaluation. How does ADK help developers test their creations?
Right, evaluation is critical. ADK provides integrated tools to systematically check agent performance. And it's not just like, did it get the final answer right?
Oh, so deeper than that.
Much deeper. It involves evaluating the entire step-by-step execution path the agent took, checking it against predefined test cases. You usually define these tests in a file, maybe evaluation.test.json or just test.json. And then you can use ADK's evaluation tools. You can do it programmatically using agent-evaluator.evaluate or through the command line with add-evil, or even use the web UI to see exactly how well your agent performs, step by step, and find where it might be going wrong.
That sounds pretty thorough.
It needs to be. That kind of rigorous testing is absolutely essential before you let any AI agent loose in the real world.
Makes sense. You need confidence they'll be reliable. Okay, finally, the deploy pillar and easy deployment. How does ADK make it simpler to get these multi-agent systems out into production?
ADK simplifies deployment primarily through containerization. You can package up your agents along with all their dependencies.
Like Docker containers.
Exactly. Package them up and then run them in various environments. While it supports deploying anywhere you can run a container, it also has really tight specific integration with something called Vertex AI Agent Engine.
Okay, what's that?
It's Google Cloud's fully managed, scalable runtime environment specifically built for AI agents. So ADK gives you a direct native path to deploy your agents onto that enterprise-grade infrastructure.
Got it. So build, interact, evaluate, deploy. ADK seems to cover that whole life cycle pretty comprehensively. Now, for someone listening who's thinking, okay, I want to try this, how easy is it to actually get started with ADK?
Well, the sources really emphasize what they call Pythonic simplicity.
Meaning it feels natural for Python developers.
Pretty much. Defining the agent's logic, the tools it uses, how it processes information. The Quick Start Guide examples seem to show you can get a basic agent running with relatively little Python code.
That's encouraging.
And what's also nice is the flexibility in how you interact with the agents while you're developing. You can use a command line interface, CLI, there's a visual web UI, an API server, or even just a straight Python API.
Lots of options.
Yeah, and the cool part is the core definition of your agent, how you write its logic, stays the same no matter which of those interaction methods you choose for development or testing.
That sounds very approachable. Okay, let's dive a bit deeper into actually building these multi-agent apps. You mentioned a weather agent example earlier. That sounds like a good way to illustrate how this collaboration stuff works.
Absolutely. The weather agent example is a great illustration of the hierarchical structure and that intelligent routing we talked about.
Okay, walk us through it.
So, you have a main weather agent. Its job is obviously handling weather queries, but it also has sub-agents. There's a greeting agent for simple hellos and things, and a farewell agent for goodbyes.
Right. Specialized roles.
Exactly. And the crucial bit is how the main weather agent decides when to pass a user's request off to one of these specialists.
And how does that delegation work? It's not like you're writing tons of if-else statements for every possible phrase, right?
No, definitely not. The smarts come from the instruction and description fields you define for each agent.
Ah, the descriptions we talked about.
Precisely. When the main agent, the weather agent here, gets a query, the underlying LLM looks at the query itself, it looks at the description of the weather agent, and it looks at the descriptions of its subagents, like the greeting agent.
Okay.
If the LLM decides that a subagent is a better match based on its description, like if the user just says hi, which clearly matches the greeting agent's description of handles simple greetings and hellos, then boom, it automatically transfers control to that agent.
So the LLM acts like an intelligent dispatcher, using the agent descriptions as, like, skill profiles to route the work.
That's a perfect analogy, and that's exactly why the documentation hammers home that clear, distinct descriptions are absolutely vital for this to work well.
Makes sense.
The LLM leans heavily on those descriptions to make smart delegation choices. If your descriptions are vague or they overlap too much, the routing might get confused or inefficient.
Right. So getting those descriptions properly dialed in sounds like a key part of building a good multi-agent system. Now, we touched on evaluation before, but why is it so critical with multi-agent systems specifically? And maybe a bit more on how ADK helps there.
Well, rigorous evaluation is even more critical in multi-agent systems, I'd argue, because you're not just checking if one agent works, you need to ensure they collaborate effectively, that the whole team behaves predictably before you expose it to users.
Right, the interactions add complexity.
Exactly. And ADK's integrated tools are designed for that systematic check. Like we said, you define test cases covering different scenarios, expected outcomes. Then you use ADK's evaluation tools programmatically, CLI, Web UI, doesn't matter, to automatically run those tests. And it assesses not just the final answer, but the whole chain of thought, the actions taken by all the involved agents. That detailed level lets you catch weird interactions or unexpected behaviors early on, way before they cause problems for actual users.
And once you've done all that testing, you're happy with the performance.
Yeah.
What's the process for actually getting it live?
ADK aims for a really streamlined path to production. Containerizing the agents gives you that portable package.
Right.
You can deploy those containers pretty much anywhere compatible. But, as we mentioned, that integration with Vertex AI agent engine is designed to be particularly smooth.
The managed runtime.
Yeah, it gives you a fully managed, scalable, enterprise-ready place specifically for running AI agents. That native integration just simplifies the whole deployment side of things, letting developers worry less about infrastructure and more about the agents themselves.
Okay. Now, there's another framework people might know from Google Cloud, Genki. How does ADK stack up against Genki? When would you pick one over the other?
That's a really important practical question for developers, yeah. The info suggests that while, both ADK and Genki are Google frameworks for simplifying Gen AI work, they have different primary sweet spots.
How so?
ADK seems specifically optimized for creating complex AI agents, and especially multi-agent systems. It offers higher-level building blocks, abstractions tailored for defining agent behaviors and how they interact collaboratively. Plus, it has that built-in support for things like LaneLM and the bi-directional streaming we discussed.
Okay, so ADK, multi-agent focus. What about Genki?
Genki is presented more as providing the fundamental building blocks for a, broader range of AI-powered experiences. It seems to have more extensive developer tooling for general iteration, testing, debugging across different kinds of AI interactions, not necessarily just multi-agent stuff. You could maybe think of ADK as the specialist tool for building intricate AI teams, whereas Genki is more of a versatile general-purpose toolkit for a wider variety of AI projects.
So it sounds like if your main goal is building those really sophisticated systems with multiple agents talking to each other, ADK is probably the more direct, maybe more powerful choice.
That seems to be the implication, yes.
But if you're working on a more general AI application, maybe needing broader flexibility, Genki might be a better fit.
Exactly. The guidance seems to be, for intricate multi-agent systems needing clear interaction frameworks, lean towards ADK. For broader AI projects needing more flexibility, wider model support, maybe beyond just agents, Genki could be more appropriate.
Makes sense. Okay, last point then. ADK is described as flexible, model agnostic, but also optimized for Google Cloud. What does that optimization actually mean for developers in practice?
Right. So while ADK is designed to be adaptable, that Google Cloud optimization gives you some real advantages if you're already in that ecosystem.
Like what?
Well, first, seamless integration with Google's own advanced models, like the Gemini family, lets you really leverage their newest capabilities easily.
Okay.
Second, as we've covered, that direct, efficient deployment path onto Vertex AI Agent Engine, the managed runtime.
Uh-huh.
But it goes deeper. ADK allows agents to connect directly into a huge range of Google Cloud services and even existing enterprise systems.
How does that work?
Through things like accessing over 100 pre-built connectors, using workflows built with Google's application integration service, getting direct access to data in places like LODB or BigQuery, even NetApp systems.
Yeah.
Importantly, without needing to duplicate the data.
Accessing data in place.
Yeah, that's a big one. Plus, ADK agents can securely talk to your organization's existing APIs if they're managed through Apigee. So this really deep connectivity makes ADK super powerful if your organization is already heavily invested in Google Cloud.
So yeah, while it's open source and flexible, being in Google Cloud gives ADK users some significant integration and performance benefits.
Precisely. It's about leveraging that whole ecosystem to build and run these next-gen AI agents effectively.
Well, this has been incredibly insightful, a really good deep dive into the agent development kit. It honestly sounds like a major step in making these complex collaborative AI systems more, well, manageable and easier to build.
Yeah, I think so too.
To just quickly recap, ADK offers precise control over how agents behave, access to a rich ecosystem of models and tools, an integrated developer experience from build to deploy, really robust evaluation tools for reliability, and that clear deployment path, especially if you're using Google Cloud.
That's a great summary. It really does look like a powerful toolkit that could empower developers to create some truly intelligent and collaborative AI applications in the near future.
Definitely. For those of you listening who want to dig even deeper, get into the code and all the details, we absolutely recommend checking out the official ADK documentation online. You'll find tons more info, code examples, the works.
Yeah, the docs are the place to go.
And of course, if you enjoy these kinds of in-depth discussions about where AI is headed, make sure you subscribe to the Before AGI podcast.
And for maybe more hands-on tutorials, other insights into AI development, feel free to check out the Ian Ochieng, that's Ochieng AI YouTube channel.
Excellent. Thanks everyone for joining us for this deep dive. We'll catch you on the next one.